Hey everybody, Mr. Odom here, and I am going to cover section 9.5, volume of pyramids, and section 9.5, extension, cross sections of three-dimensional figures. So the learning targets for these lessons are, by the time I'm done, hopefully you can say I can find the volume of pyramids, and I can describe the intersection of planes and solids. You'll need a pencil, composition book, or notebook paper to take notes, and a calculator. So off we go. So there's a formula that you need to know for the volume of a pyramid. And it's right there. Volume equals 1/3 times the area of the base. Capital B means area of the base, times the height of the pyramid. And the height of the pyramid goes from the base of the pyramid all the way up to the vertex. Okay, so that's different than the slant height of a pyramid. So what is the slant height of a pyramid? Okay, so hopefully you guys remember what a slant height is. Another way that I like to write this formula, and the way that I use it, is I write the volume equals area of the base times the height divided by 3. So for this formula, you're multiplying by 1/3, and this formula, you're dividing by 3. Either one, whatever one you're careful with, either one you're comfortable with is fine. All right, let's practice. So I've got a pyramid. It is a rectangular pyramid. And so here's our steps. First, write the formula down. Volume equals area of the base times the height divided by 3. Bam, there it is. Let's find the area of the base. So in this case, since this is a rectangular pyramid with the base having those dimensions, there's a length and here's a width. That's the formula I'm going to use to find the area of the base. So let me multiply 10 times 8 and I get 80 inches squared. That's capital B. All right, now we plug that in to our formula. What is the height? The height of the pyramid is 7 inches. 80 times 7 divided by 3. So the volume equals 560 over 3 inches cubed. Or if you want to write it as a mixed number, some of you like to do that, 186 and 2/3 inches cubed. And there's your volume. All right, so there's an example. Let's look at another one. So here is another pyramid, and if we look at the base of this, we see the base of this pyramid is a triangle. So what kind of pyramid is this? Classify it. Very good. It is a triangular pyramid. So let's write the formula down. Formula, volume equals area of the base times the height divided by 3. What is the area of the base? Well, it's a triangle. So the formula for the area of a triangle is base times height divided by 2. And I could call this my base if I want, or this my height. It doesn't really matter. You could swap that around because both numbers are going to be multiplied together in the numerator. Okay, I can cancel. And I'm left with the area of the base equals 7 times 9, which is 63 centimeters squared. All right, so now all we have to do is plug that into our formula. I've got 63 times 11 divided by 3. Again, there's more canceling. That's 1. 3 goes into 63 21 times. And I'm left with 21 times 11. All right. And there was a trick that we used to multiply by 11. I remember showing you that in class. To multiply by 11, you need to take the 2 digits, the 2 and the 1, put a space in between them, and then just add these 2 digits together and put that answer right in the middle. And we attach some units. Remember, volume is always cubed. And there you go. We've got our volume. All right, next problem. Here I've got 2 bottles of sunscreen. This bottle is bigger than that bottle. Okay, this bottle costs more than this bottle. You want to figure out how many times bigger is that bottle than that bottle. So we got to find the volume for each one of these bottles. All right, so let's do that. So for bottle A, all right, the volume equals area of the base times the height divided by 3. What is the base? Well, here it is. The length is 2, the width is 1. So capital B, you can do that one in your head, right? Capital B is just 2 times 1, which is 2 inches squared. So the volume is going to be 2 times the height, which is 6, divided by 3. All right? And 2 times 6 is 12. 12 divided by 3 is 4. So the volume of bottle A is 4 cubic inches. What about for bottle B? We use the same formula. Volume equals area of the base times the height divided by 3. And what is the area of this base? If you said 4.5 inches squared, you'd be correct, because I'll take that as my length. That is my width. 3 times 1.5 is 4.5 inches squared times the height, which is 4, and that is divided by 3. All right, so this volume is going to be 4.5 times 4. 4.5 times 2 is 9. So 4.5 times 4, you double that, and then double it again. So it's 18, and 18 divided by 3 is 6 inches cubed. Okay, so how much bigger is this bottle than this bottle? Well, how do we figure that out? We take the 6 inches cubed and divide it by the 4 inches cubed. And when you figure that out, you do the math, you get 1.5 times bigger. All right, we still have a question to answer. Which one is the better buy? How do we do that? Well, the way we do that, it says here, to determine which is a better buy, that's this step, step 7, calculate the unit cost for each bottle. And so let's calculate the unit cost. So for, let's see, the cost for bottle A is $9.96. So if I look at the, let's see, the cost over the volume. All right, what does that look like? So for bottle A, it would be $9.96 divided by 4 cubic inches. What about for bottle B? What was that cost? That was $14.40. So this one would be $14.40 divided by 6 inches cubed. And again, this is going to give us our unit cost. All right. And so unit cost, think of that as a unit rate. So let's turn this into a unit rate. So a unit rate, remember, has a 1 in the denominator. All right. And so to go from 6 to 1, I need to, that's right, divide by 6, which means I need to divide the numerator by 6. And when you do that, you get $2.40. So for 1 cubic inch of bottle B, the sunscreen in there, it costs $2.40. What about for bottle A? We do the same thing. We want to turn this into a unit cost or unit rate. So this one I divide by 4. So I divide the numerator by 4. And that will give me an answer of $2.49. So if I look at these unit costs and I compare them, which one of these unit costs should I put a circle around? $2.49 for 1 cubic inch or $2.40 for 1 cubic inch? Very good. You are now a comparison shopper. All right. So that's the one you should buy because it has a better cost per cubic inch of sunscreen. All right, so that's that problem. Let's move on and quickly talk about 9.5 extension. You guys are going to find this to be an easy peasy section. So what you want to do is consider, look at this drawing. You want to look at this plane, which is right here. And this plane, and I'm going to have this plane intersect this solid. Okay? All right, that plane is going to intersect that solid. And where that intersection is, where it takes place, you see there in purple, you see here in purple where the intersection takes place. All we'd have to figure out is what shape is that, right? So for this one, it says, for example, the diagram shows that the intersection of the plane and the rectangular prism is a rectangle. Okay, that's all we have to do for this section. I know, right? Too easy. Even Mr. Odom can do this. That's what you need to tell everybody. Even Mr. Odom can do this. So let's look at a couple of these. So describe the intersection of the plane and the solid. So the plane is intersecting, looks like a pyramid. And the way that it's intersecting the pyramid, the purple shape is a triangle. Told you I could do it. And for B, the intersection of the plane and the rectangular prism is a rectangle. And for C, the intersection of the plane and the triangular prism is, I know, it's too easy, right? A triangle. That's all you have to do for this section, all right? I don't have anything else up that squiggly line there, which helps me to be able to scroll. Anyway, enough of that. So we covered 2 sections. 9.5 took like 45 seconds. You guys got it. That's all you have to do for that section. We also talked about how do you find the volume of pyramids, a really important formula. You need to know this formula. All right, you're going to be using that one. You'll see it again. All right, so hopefully now you can say I can find the volume of pyramids and I can describe the intersections of planes and solids. And this is Mr. Odom. This has been fun making these videos for you. And I got to go. So I'm going to take myself and I'm going to get out, Mr. Odom. Get out. Bye.